Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we are discussing files and indexing. In this session, we are going to discuss some problems, previous questions from GATE exam on multi-level indexing. So let us start the session. The first question is, in a B plus tree, the requirement of at least 50% node occupancy is relaxed for which one of the following cases? In B plus tree, every node should have, what is the number of nodes, sir? Whenever I have order n, if it is internal node, what will happen, sir? I will have maximum number of pointers is n. Maximum number of keys is n minus 1. What about minimum? Minimum pointers will be n by 2 seal. What about minimum number of keys? That is n by 2 minus 1. So in every node, I need to have at least n by 2 minus 1. This is roughly equal to or almost equal to 50%. So every node should have minimum of 50% of values in that particular node. Okay, so that is about internal node. Even for leaf node, when I have leaf node, suppose the order is m. What is the maximum number of keys? Sir, here we don't have any pointers because it is a leaf node. So we don't have any children for leaf node. So we need to discuss only keys. The maximum number of keys is m. What about minimum number of keys? The minimum number of keys is m by 2 floor value. So this is also equal to 50%. Right? So in B plus tree, every node should have at least 50% of key values. That is the condition. But this condition is relaxed for one particular node or for some particular set of nodes. What is that particular node? Sir, every leaf node, every internal node should satisfy this condition. There is no other choice. But only the root node can have minimum one key in any situation. Either it is in B tree or it is in B plus tree. The root node can have minimum one key. Maximum n minus 1 keys, because that is the maximum number of keys allowed. So for root node, I can have minimum one key. There is no rule that the root node also should contain 50% of the nodes, because when you are splitting the nodes and the split forms a root node, that root node should have only one node, one key value. So if I give this condition 50%, I cannot split that node to form the new root node. So root node is having the relaxation for 50%. So this is our answer. Hope you understood it. I'm sorry. Let us go to the next question. Consider B plus tree in which the maximum number of keys is 5. What is the minimum number of keys? Okay, the question they given is maximum number of keys. Maximum number of keys, sir. Right? Now I don't know whether of course they given non-root nodes are, so it's very clearly non-root node. Otherwise you can solve with leaf node also, sir. Anyway, they given non-root node. Whenever it is a non-root node, there are two possibilities. Either it can be internal node, either it can be internal node, or it can be leaf node. Either it can be internal node or it can be leaf node. Let us solve the cases separately. Let us assume the first one, it is internal node. Whenever internal node, what is the minimum keys, sir? The formula for minimum keys is equal to n by 2 seal value minus 1. Now the question is, what is order n? They not given any order n, sir. Then how to find it? Sir, maximum number of keys is 5. So what about maximum number of pointers? The order n equal to maximum number of pointers it can have. Whenever I know pointers, I can calculate the number of keys. Whenever I know keys, I can calculate the number of pointers. That is 5 plus 1, which is equal to 6. So if you apply here, this will be equal to 6 by 2 minus 1. So which is 3 minus 1, that is equal to 2. This is in the case of internal node. Hope you understood it. Now let us suppose that it is a leaf node. Whenever it is a leaf node, what is meant by order m, sir? This is maximum number of keys. In this case, what is maximum number of keys? That is 5. Now the question is, what is the formula for minimum number of keys? Minimum number of keys is equal to m by 2 floor value, and that value is equal to 5 by 2 value, which is equal to 2. So in any case, we got 2, sir. So the answer is 2. If they give clearly it is not a leaf node and it is a internal node, then you can apply only the first technique. Here, since they not given, we verified both, sir. Let's go to the next question. The order of an internal node, the order of an internal node in a B plus tree is the maximum number of children it can have. The same formula they given, the same definition they given, sir. Order of internal node. This we already know, sir. Okay, but they given for more clarity. So what is it, sir? The maximum number of children. Maximum number of children means that is equal to maximum number of child pointers. This is the definition we have learned, sir. The same definition they given. Now what is the question? Suppose a child pointer takes 6 bytes, fine, and search field takes 14 bytes, and the block size is 512 bytes. What is the order of the internal node? So we need to find the order of internal node. According to the definition of internal node, if I assume order equal to n, what will happen, sir? It will have maximum n number of child pointers. Am I right, sir? It will have maximum n number of child pointers. Anything else, sir? it will have n minus 1 such key values. Sir, it don't have any pointers to the data blocks because it is a B plus tree. So this is the only story you need to have. All these must fit in a block. Am I right, sir? All this must fit in a single block. So they given the block size also. Now let us write the formula and solve for the value of n. So this is what they given, sir. N number of child pointers plus n minus 1 number of keys. The sum of all these sizes must be less than or equal to block size. So this is the formula what they given, sir. We don't know the value of n. What is child pointer size? 6 bytes. N minus 1 into what is search field, sir? That is 14 bytes. This must be less than or equal to 512 bytes. So let us simplify it. 6n plus 14n minus 14 less than or equal to 512. Hope I think this is 20n less than or equal to 512 plus 14. 20n less than or equal to 526. N less than or equal to 526 divided by 20. What is this value, sir? I think it is 263. 26.3. So what can be the value of n, sir? That is 26. So what you got, sir? You got order. Order n equal to 26. What they given, sir? What is the order of internal node? Yes, of course, it is 26. Hope you understood it. If you have any doubt, please raise in chat box so that we will discuss it again. Let us move to the next question. Yeah. The order of a leaf node. The order of a leaf node in a B plus tree is the maximum number of value comma data record pointer. This is what we have, sir. Whenever this is a leaf node, this is my leaf node, sir. Whenever you are saying leaf node, and if you said the order is m, what will happen, sir? It will have m number of keys. Suppose the order equal to m. This is a leaf node, sir, because they are discussing about leaf nodes. Leaf node. Fine. Then value comma record pointer. What does that mean, sir? First of all, it will have m number of keys. This is the first point. Now, key means it is not key, sir. Key value plus pointer to the data record. Pointer to the data record which contains that particular value. This is what we have learned. The same they given, sir. Value comma data record pointer. So this is record pointer 1, record pointer 2, because in my intention key means it is a combination of key value comma the pointer to the data block which contain our key value. Similarly, the same story for second key. And you can write for the third one also. The last one also the same, sir. What about this lot, sir? This is the pointer to the next leaf node. Okay, so it's a child pointer to the next leaf node. Right, sir? Now let us list out what a leaf node will have. First of all, it will have n number of key values. If I assume it is order n, of course we assume order is m, right? So let me write m. M number of keys. Since I have m number of keys, I will have m number of record pointers or data pointers. I will have m number of record pointers or data pointers. And I have one child pointer. And I have one child pointer. So in this case, please observe, sir, given that the block size is 1k bytes, data record pointer they given, the value field 9 bytes they given, block pointer. Sir, if this is data pointer, what about this pointer, sir? That is, they used the terminology block pointer. So their intention is block pointer is child pointer. So these are the things I need to fit in a single block. What is the block size? The block size they given is 1k bytes, right? So this is the story you are having, sir. Now let us find the order of leaf node. Right? M number of keys, m into key size, plus m number of data record pointers. Right, sir? So let me write record pointers plus one child pointer. That child pointer they given as block pointer. This I have only one, sir. All this must be less than or equal to block size. Hope you understood, sir. I have m number of pairs, key values, comma, record pointers, and one block pointer or child pointer. So that is what we written. M value we don't know, sir. What is key size? This is key size, sir. Instead of key, they told value field. So key size is 9 bytes plus m into record pointer or data pointer, that is 7 bytes, plus one block pointer, that is 6. And what about this 1k, sir? 1k means 1024 bytes. So this is less than or equal to 1024. I think this will be 16m plus 6 less than or equal to 1024. Let us simplify this equation, sir. Sir, once we are ready with the equation, the rest is mathematics only. So this will be 1024 minus 6. 16m less than or equal to 10, 18. M less than or equal to 10, 18 divided by 16. So how much it will, sir? I think 6 times, then 118. 118 means 80, 96, 102, 112. So 67 point something. Okay. So let us assume something 3. So what can be the maximum value, sir? 67. This is the order of the leaf node. Sir, please check it, sir. I am not sure about the numerical calculations. Most probably it will be correct. Okay. 118 means it will be 96, 11, 102, 112, fine. So it will be 67 point something, sir. So the order is 67. Let us check. Yes, we have, sir. The order is 67. Please go through it. And if you have any doubt, please raise in chat box. Let us move to the next question. Yeah. Consider a B plus tree. Consider a B plus tree. Fine. In which the search key is 12 bytes. So the first point they given is search key is 12 bytes. Block size 1024 bytes. Block size 1024 bytes. Record pointer is 10 bytes. Record pointer is 10 bytes. And block pointer is 8 bytes. Sir, the most important task or the tough task is whenever they given like block pointer and record pointer, first I need to identify the terminology, what they are following, right? So generally the block pointer means it is child pointer. Then record pointer means it is data pointer. Then how to remember it? Sir, record, where the record will be stored? The record will be stored in the data block. So whenever they said record pointer, please remember it is data block pointer. Like that I remember, sir. So you can also do the same story. So this is what we are having. Fine. Now the maximum number of keys it can be accommodated. The maximum number of keys that can be accommodated in each non-leaf node. So the task is we need to find the internal node. In internal node, what you supposed to find, sir? Maximum number of keys. What is maximum number of keys? N minus 1. Now the question is, what is n? I don't know. That is order of the tree, order of internal node, but they not given any value. So the first task is I need to identify n value. Then the answer is not n, sir. It is n minus 1. Please remember it. Here they didn't ask for order. They not given the question for order, sir. They given the question for max keys. So the answer is not n. It is n minus 1. First observe this point and start the problem, right? Because if you don't observe this point, immediately after solving it, directly you can write the n value, right? So we have already solved the problem. Just by small mistake, we lost the marks. So please keep this point. What they are asking in the question, thus first we need to observe. Now let us do it. So when coming to leaf node, as we told, let us assume the order is n. Whenever I assume order is n, what will happen, sir? It will have n number of pointers. What is this pointer, sir? These pointers are child pointers. Here the child pointers means block pointers. What is the size of block pointer, sir? 8 bytes. Then since I have n pointers, it will have n minus 1 keys. What is key size? 12 bytes. Now for internal node, do you have any record pointers? No, sir. Just they given the data to confuse us. Okay, because in internal node we don't store any data record pointers, or we don't have any pointers to the data blocks, so we don't need this value. Leave it, right, sir? So what is the equation you are having? N into the block pointers plus n minus 1 into keys. This must be less than or equal to block size. This is the equation it need to satisfy. Now let us substitute the values. N value we don't know, sir. Block pointer is 8 bytes. N minus 1 into what is key size? The key size is 12, sir. So the entire value must be less than or equal to block size. What is block size, sir? 1024. Now let us solve it. 8n plus 12n minus 12 less than or equal to 1024. I think this will be 20n less than or equal to 1024 plus 12. Am I right, sir? So 20n less than or equal to 1036. I mean 1036. So n less than or equal to 1036 by 20. What is this value, sir? I think 518. So it is 51.8. 51.8. What is n value, sir? 51. What is the answer, sir? Sir, the answer is not n. Max number of keys is equal to n minus 1. That is 51 minus 1, which is equal to 50. Sir, please check the numerical calculations. I am not sure. So 1036 it is 518. Hope it is clear. So the answer is 50. Please go through it. And if you have any doubt, please raise in chat box. Let us go to the next question. Right. A B plus tree index is to be built on the name attribute. Sir, on the name attribute means this is our search key. One minute, sir. This is our search key. Fine. Of the relation student. Assume that all the student names are of length 8 bytes. So student name, that is our search key. This is equal to how many bytes, sir? 8 bytes. Fine. Disk blocks are of size 512 bytes. So block size. Block size is 512 bytes. Fine. Index pointers are of size 4 bytes. Sir, please observe. Now they used some different terminology. Index pointers means the pointers which we use to point to index nodes. Index nodes means what, sir? Child pointers. So index pointers. That means pointers to the index nodes. Where we will have index nodes, we will have in B plus tree. So what does it mean? Index pointers equal to child pointers. So this child pointer is of 4 bytes, right? Given this scenario, what would be the best choice of degree? The number of pointers per node. Sir, please observe it. We need to find the number of pointers. The question is about which node they asked, whether it is an internal node or it is a leaf node. About which type of node they raised the question. Is it an internal node or is it a leaf node? To decide this, there are two possibilities, two ways. The first way, if I want to find the order of leaf node, I need three things: search key, child pointer, as well as data pointer. Here I don't have data pointer. Whenever I don't have data pointer, it is not possible to conclude about the order of leaf node. This is the first way. So that's why the question is not about leaf nodes. The second way, the number of pointers per node. Sir, always it will be the number of pointers per node. Which pointers? So that will be about either child pointers or the pointers to the original node. But I don't have any data about the data pointers. So hopefully they given the data about internal node. Sir, I also don't know what the intention is there in their minds, but based on the given data, I am assuming that they raised the question about internal node and we are solving for internal node. Okay, I don't know whether it is exact intention of the question, right? So let us do it. Now we are discussing about internal node, right? Let us suppose the order is n. Whenever you assume order is n number of child pointers, n minus 1 number of keys. That's it. So what is the formula, sir? N number of child pointers plus n minus 1 number of keys. The sum of all these sizes must be less than or equal to block size. Am I right, sir? So n value we don't know. What is the size of child pointer? That is index pointer. Index pointer is nothing but child pointer. So that I have 4. N minus 1 into key size. Sir, here key means what? The field with which you are searching, and you are searching with the help of name. So this is my key. How much size? It is 8. And what is the block size? They given 512. So this is 4n plus 8n minus 8 less than or equal to 512. So that will be 12n less than or equal to 512 plus 8. Hope I think this is 512 divided by, 520 divided by 12. How many times, sir? I think 4 times. In 40 it is 3 times. Again it will be this one. So n must be less than or equal to 43.3, but n is a integer, sir. So the maximum possible value for n is 43. So this node will have 43 pointers max. Hope you understood it. So that is 43. Hope you understood it. So we are moving to the next question. Yeah. The following key values are inserted. The following key values are inserted into a B plus tree. Fine. In which order of internal node is 3 and that of leaf nodes is 2. The given order of internal node is 3 and order of leaf node is 2. Very clearly. Fine. And in the sequence given below, the order of internal nodes is the maximum number of tree pointers in each node, and the order of leaf node is maximum number of data items that can hold. The same definition they given, sir. Now the B plus tree is initially empty. The maximum number of times the leaf node would get split up as a result of these insertions. Sir, the first important point is B plus tree, right? So when coming to leaf node, what is the order, sir? 2. What does it mean? A node can have maximum of 2 values. So whenever I have 2 values, suppose 10, 40, there is no issue. If it is having more than 2 values, 10, 20, 40, it is violating the rule. Then we need to move median to the next level. So this one to the next level. So whenever you move this node to the next level, I will get like this. For leaf node, I have only one median. That median I am moving to next level. So everyone will need to do the same process. But please observe the internal node. In internal node, the order of internal node is 3. Yeah. 3 means what, sir? The order of internal node is the maximum number of tree pointers. So it will have maximum 3 pointers. Whenever it is having maximum 3 pointers, how many values it can have, sir? It can have 2 keys. Okay, the same story, sir, I think. Okay, so whenever I have 1040, there is no issue. Okay, now let us suppose I have some 10, 30, 40. Then since it is having more than the requirement, I need to move this node to the next level. So this is what you are having, sir. Right? Now let us do it. The sequence they given is 10, 3, 6, 8, 4, 2, 1. Let us start it, sir. Right? Sir, always the first node which you are considering is a leaf node. In leaf nodes, we will have the original data records. Sir, original data record in the sense, original index record. Original index record means key value plus pointer to the data block. So to indicate that, let me write ten star. Then the next node is 3. So 3 star, 10 star. Sir, why I am writing star? 3 means it is not only 3. 3 plus pointer to the data block. That one only. Now let's go to the next one, 6. So 3 star, 6 star, 10 star. Now it is violating because I can have maximum 2 keys. Move this to the next level. Right, sir? Now please observe it. Whenever I write this one, whenever I split the leaf node, directly I cannot write it because in B tree I can write it. But in B plus tree, I need to maintain this copy either in right side or in left side. What does it mean, sir? The first possibility is you can have 20 star, 40 star. That means I am maintaining the original in the right side. Instead of this one, the same I can do. So the original I maintain in left. Now the question is, which I need to follow? Sir, we need to solve both because we need to find the maximum number of splits. So first we do for right side, then we do for left side. So whichever gives maximum, that is our answer. So here we are assuming, let us move right bias. Right bias means the original value we maintain in right side. So this will be 6 star 10 star. The left is 3 star. Now let's go to the next value. So 10 completed, 3 completed, 6 completed, then 8. So 6 fine, 6 star, 8 star, 10 star. Three star. Sir, please observe it. Again, it is having more possibilities, more keys. So we need to move this. So whenever you move this 6, 8, and you are maintaining in right side 8 star, 10 star. In the middle, I have 6 star. To the left of 6, I have 3 star. So we inserted 4 keys. What about next key? 8 completed, right? Then 4. I think 4 will come to this node, sir. So 6, 8, 3 star, 4 star. Then 6 star, 8 star, 10 star. Done. Then 2 star. 2 will come to again the leftmost node. So it will be 6, 8. So it is 2, right? 2 star, 3 star, 4 star. To the middle, I have 6 star. Then we have 8 star, 10 star. What I need to move, sir? It is having more values. So I need to move this middle value to the next level. But please observe it. If I move this 3 to the next level, it is also having more values. Again, I need to split up. So first let me write it. 3, 6, 8. For 2, it is 2 star. Here it is 3 star, 4 star. Then 6 star. Then I have 8 star, 10 star. Sir, please observe it. This is having more values. I need to move this to next level. Now, when you are splitting internal node, again, no need to maintain duplicate copy because it's already a duplicate copy. So what will happen, sir? The tree will be like this. I move 6 to the upper level. Then to the left of it, I have 3. To the right of it, I have 8. Please observe it. We are not maintaining any duplicate copy. Then I have 2 star, 3 star, 4 star. What about this 8, sir? This is 6 star, 8 star, 10 star. The last value is 1. So where the 1 value will come, sir? The 1 value will come to in this node. So then the final tree will be 1 star, 2 star. This is 3 star, 4 star. The left is 6 star. The right is 8 star, 10 star. Sir, what the question they asked me, sir? The maximum number of times leaf node. So we need to count only splits of leaf nodes, not of internal nodes, right? So let us count it. This is the first time we got, sir, leaf node. This is the second time we got, sir, and where you have this is the third time. Here we split, but it is not a leaf node. So totally we split the leaf node only for 3 times. So totally how much you got, sir? 3 times. Sir, this is when you are maintaining the original copy in the right side. That means when we are taking right bias. Now the number may increase or decrease if I maintain the original copy in left side. That means if I use left bias, the 3 may be increased or the 3 may be decreased. I don't know. So compulsorily we need to verify the second possibility also. The same sequence we are going to do for left bias. Hope you understood up to here. Now let us do the same story, sir. So the first value is 10 star. The second one is 3 star, 10 star. The third one is 3 star, 6 star, 10 star. Please observe this leaf node is having more values. So I need to take the median to the next level. So 6, then now I maintain the original copy in the left side, not in the right side. So it will be 3 star, comma 6 star. Sir, please observe it. This is the original copy you are maintaining in left bytes. Left bias. Now let us do the next value. I think we completed 10, 3, 6, then 8. The 8 will come to the right of this, right? So 6 is fine. 8 star, 10 star, 3 star, 6 star. Then what about next value? 4. I think 4 will come to the left node. 6 to the left of it. 3 star, 4 star, 6 star. To the right of it, 8 star, 10 star. The left leaf is having more values. Move this value to the next level. Then it will be 4, 6. Now this one I need to maintain on the left side. 3 star, 4 star. The middle one is 6 star. Then I have 8, 10. So we completed 4 also. Then we have 2 star. So the next value is 2. So let us write it, sir. 4, 6. 2 will come to this part. 2 star, 3 star, 4 star. Then 6 star. Then 8 star, 10 star. Sorry, sir. So this node is having more values. Move this. Sir, when you move to internal node, it is also having more values. Again, the split will take place. 3, 4, 6. So this is 2 star, 3 star. This is 4 star, 6 star, 8 star, 10 star. Now this internal node is having more values. Move 6 to upside. Sorry, it's 4, right? So 3, 6. Then to the left of 3, I have 2 star, 3 star. To the right, I have 4 star. To the left, I have 6 star. Then you have 8 star, 10 star. The last value is 1, sir. Please observe the 1 will come to the leftmost node. So 2 star, 3 star, 1 star. Then 4, 6, 8, 10. Now this is having more values. Move to the next level. So 4, 2, 3. Then 6. When coming to the left, it will be 1 star, 2 star. This is 3 star. This is 4 star. When coming to here, it is 6 star. The last one is 8 star, 10 star. Hope you understood it. Now let us count how many times the split has taken place in leaf nodes. So this is the first time it's a leaf node. This is the second time. And this is the third time. This is the fourth time. So whenever you maintain left bias, how many you got, sir? 4. Whenever you maintain right side, you got 3. So the maximum number of splits in leaf nodes will be 4. So what is the answer for this question, sir? That is 4. Hope you understood it. Let us move to the next question. Yeah. Consider a database. Consider a database implemented using B tree. Yeah, this is our first point, sir. So they are using B plus tree for index file, for file indexing, and installed on a disk drive of with block size 4 bytes. So the second byte is block size 4 kilobytes. Sir, 4 kilobytes means how much, sir? It is 4 into 1024. Which is equal to 4096 bytes. Hope you understood it. Fine. Now, the size of search key is 12 bytes. Size of search key is 12 bytes. Fine. The size of tree pointer or disk pointer. So clearly they given tree pointers are, it is more convenient to us. So tree pointer is of 8 bytes. Fine. Assume that the database has 1 million records. Sir, it is having 1 million records. This is most important point in this problem, sir, I think. So the database has 1 million. Sir, 1 million means I think it is 10 lakhs. 10 lakhs means it is 10 power 6. Please check it, sir. Now, assume no node of B plus tree and no records are present initially in the main memory. So we don't have any records in the main memory. Every record I need to bring from the secondary storage to RAM to work on it. Consider that each record fits into one disk block. So the same we are assuming, sir, every record fits in one disk block. The minimum number of disk access required to retrieve any record in the database. Right? Now, before going to that one, what is the number of access we need for B plus tree? Sir, suppose I have a B plus tree like this you are having, sir. This is our leaf node. This is our leaf node, sir. So now what is the access cost? Okay, what is the access cost? Suppose I am searching for 22, sir. What you do, sir? You compare with this node. That means I need to bring this node from secondary storage to main memory. Because to do comparison, that node should be in the main memory. After comparison, either I move to left or I move to right. Let us suppose we move to left. Then again I compare 22 with this node. So this is my second comparison. Then either I move to left node or I move to right node. Suppose I move to right side. Then I will compare with this. This is our third one. Then with that I go to this node. With that I will go to this node. So this node I need to bring to the main memory. Whenever I bring this node to memory, what you supposed to get, sir? Address of the data block. So by 4 index nodes, I am able to get the address of index block. Now I need to get that original block. The original block. So 4 index blocks plus original data block. Totally how many, sir? 5 blocks. 5 blocks. So what does it mean, sir? If I assume this is level 1, level 2, level 3, level 4. So totally 4 levels plus 1 block to the original one. So this is the number of disk access we require to access any record in the database. So first I need to count the number of levels. How many levels you are having in our tree? Plus 1. Because after we went to leaf node, we will get the address of the original one, sir. Hope you understood it. So number of levels plus 1. Now the question is, what is number of levels in this context? Or how to find it? How will you find, sir? All these 1 million records, should fit in the last leaf nodes. Because I need to maintain the address of each and every record in the leaf nodes. So the last level should contain 1 million records. 1 million records are not number of nodes. Suppose a record is having 100 records. Suppose a node is having 100 records. I need only some 10,000 nodes. So I don't know, right? So that I need to count. Let us start it. First, let us find order of internal node. Sir, we don't need order of leaf nodes, sir. Because when we are clear about internal nodes, the last level is leaf nodes. So just I need to find the order of internal node. So what is the formula of internal node? N number of keys n minus 1 number of disk pointers. That is they given already. So this is less than or equal to block size. 1 minute, sir. Yeah, fine. So n is fine. Key size is 12 bytes. N minus 1 into disk pointers 8 bytes. This is less than or equal to 4 KB, sir. This you already calculated 4096. This is 12n plus 8n minus 8 less than or equal to 4096. What is this value, sir? 20n less than or equal to 4096 plus 8. Sir, whenever I am doing any numerical mistake, please let me know, okay? So this is 20n less than or equal to, I think this is 4, 0, sorry. What is this value, sir? 4104, am I right? Yeah, 4104. So n less than or equal to 4104 divided by 20. So this is 2 times 05.2. So what you are having, sir? N less than or equal to 205.2. So n is 205. So the order of internal node is 205. Sir, what is the meaning of order, sir? We have 205 pointers. What does it mean? You will have 204 keys. 205 pointers and 204 keys. So this is what we got till now. Now I know how many keys I can write in a node. Whenever I know in a node how many keys I can write, I can find the number of nodes, right? So I need to expand the B plus tree so that the leaf level should contain minimum 10 lakhs. 1 million means 10 lakhs. Maybe more than 10 lakhs, sir. But if the last level is containing only 9 million, if it can hold maximum 9 million, where I need to write the remaining? Sorry, it's not 9 million. If the last level contains only 9 lakhs, where I should write the remaining 1 lakh? So I need to form the B tree, B plus tree, such that the last level can have minimum of 1 million, that is 10 lakh records. Let us do it. Okay. Let us write leaf, sir, level, and number of nodes in that particular level. Whenever I know the number of nodes, I can write the number of pointers, and I can write the number of keys. Let us assume the B plus tree contains only one level. Then what does it mean, sir? In that one level, in all those nodes, I need to fit all the 1 million records. Is it possible? Let me check it. Okay, sir, surely always the root level. Let us continue the level 1. In level 1, let us assume I have only one node, right? Then what is the number of pointers, sir? What is the order they given? 205. So the number of pointers is 205. The number of keys is 204. Hope you are clear up to here. So in first level, I have only one root node. This is my root node, sir. Now let's go to the second level. Sir, the first simple question, what is the number of nodes in second level? When the root node is having 205 pointers, every pointer will have this one. Suppose this node is having 5 pointers. What does it mean, sir? This level is having 5 nodes. Am I right, sir? So this number of nodes is equal to number of pointers in the previous level. This is 205. Am I right up to here, sir? Now, one node is having 205 pointers. One node is having 205 pointers. 10 nodes will have how many pointers, sir? 20 into 10. 100 nodes will have 205 into 100. Like, if I have 205 pointer nodes, how many pointers I will have? 205 into 205. Total it will be 205 square. Or you can simply write 205, sir. So the number of pointers is 205 into 205. Am I clear, sir? What is the number of keys? Sir, one node will have 204 keys. 205 nodes I have. How many I will get, sir? 205 into 204. Suppose if this is greater than 1 million, then it was done. I have only 2 levels. Because in the last level, I am able to fit all 1 million records. What is the value of 205 into 204, sir? I also don't know. Let me calculate it. 205 into 204. I think this we will get 41820, sir. So compulsorily I need to move to the next level. I don't have a choice. Right? So let's move to the next level. Level 3. Sir, how many nodes you will have, sir? The nodes in this level equal to the number of pointers in the previous level. What is the number of pointers? 205 into 205. This is the number of pointers. How many pointers in this node? Sir, one node is having 205 pointers. This number of nodes will have 205 into 205. This is the number of nodes, like 100. Every node is having 205 pointers. This is the total number of pointers. How many keys you can have, sir? 205 into 205 into 204. Because one node is having 204 keys. So this will have 205, 205 into 204. So what is that value, sir? 205 into 205 into 204. So I think this we are getting 8 lakhs. This is also not enough, sir. So I need to move to the next level. Now, can you give the number, sir? This is 205, 205 into 205. Sorry, I think this is equal to the number of points on the previous level, right? This is. Then how many pointers you will have, sir? 205, 205, 205. This is the number of nodes. For every node, I have 205 pointers. What is the number of keys? 205, 205, 205. This is the number of nodes in this level. So the keys will be 204. What is this value? 205 into 205 into 205 into 204. I think we got very big number, sir. So this is equal to sir, I think this is up to 4 lakhs, 74 lakhs. So we have more than, sir, right? It is 85,000, right? So 4 lakhs. So we have 4 lakhs. But 1 million means only 10 lakhs. So 4 levels are enough. So I have 4 levels are there in B plus tree. What is the access cost? The access cost is equal to levels plus 1. So it is 4 plus 1, which is equal to 5. Hope you understood it. Please go through it, and if you have any doubt, please raise in chat box. Let us move to the next question, sir. Yeah, I think it's a theory question, sir. B plus trees are considered balanced. Sir, why it is balanced, sir? Always the leaf nodes are at the same level. Please observe it. All the B trees and everything, all leaves are at same level. In all the previous diagrams or all the problems, we have seen it. I think they will give it, sir. The length of paths from root to all leaf node are equal. Sir, this is same, right? All leaf nodes are same, or length of paths both are same. So all leaves have same path length from root. Same path length from root. What does it mean, sir? Same level. Right, sir? The number of, well, let me verify the remainings also. The lengths of paths from root to all leaf nodes differ from each other by at most 1. There is no difference, sir. Every leaf node is at the same level. The number of children of any two non-leaf sibling nodes differ by at most 1. We don't have these two options, sir. The number of records in any two leaf nodes, every leaf node will have same number of records. Okay, so that's the first option, sir. Please go through it. Now let's move to the next one. Which of the following statements is not correct? Not correct, sir. About B plus tree. Fine. B plus tree is a height balanced. Yes, of course. Because leaves are at same level. This is true, sir. But they asked about false statement. Non-leaf nodes have pointers to data records. Yes, of course. Every leaf node, non-leaf node, no, sir. Only leaf nodes will have, sir. Only leaf nodes will have pointers. Only leaf nodes will have pointers to data records. Non-leaf nodes are internal nodes. They don't have, sir. They have only child pointers. So this is not correct. Every leaf node has a pointer to the next leaf node. Yes, of course, this is what you are having. The last slot is to point to the next leaf node. Key values in each node are kept in sorted order. Of course, this is true for B plus tree or B tree also. So the second statement is not correct. So this is our answer, sir. Since it is not correct, that is our answer. Okay. Please go through it, and if you have any doubt, please raise. Now let's move to the next one. Yeah, I think it's very lengthy question, sir. Anyway, I think it's a very recent question from data science paper. A OTT company is maintaining a large disk-based relational database. So they are maintaining a relational database. That is what we have discussed till now, right? Relational database, fine. With the movies, the first table is movie ID, comma customer rating. So the first table is having only two attributes. One is ID, the second one is customer rating. The second table is genre. Okay, the second table is genre. It is having also two attributes. One is ID, the second one is name. The third one is movie genre. So movie ID, comma genre ID. Fine. Consider the following SQL query on the relational database. Select star from movie, comma genre, comma movie genre. So all the three tables they are combining, sir. Where movie dot customer rating greater than 3.4. Sir, whenever it is greater than 3.4, it's a range query. So I need to find from 3.4 to the last one. So it's a range query. That's the first one. Then genre name equal to comedy. So it is only equality query, sir. So let me write it. Equal to comedy. So that is not a range query, sir. It is equality. Then again I have two more. These are only to combine the tables, sir. Since you are dealing with the two tables, you are combining these two, sir. So I have one range query, one equality query. The first thing is whether it is a range query or equality query. If you apply B plus tree, it will give less time or less access cost, because in B plus tree, the access cost equal to number of levels plus 1. So either it is a range query or equality query. Always B plus tree will give less cost. So this is always. And in DBMS, we have not discussed hashing techniques. But what is the main specialty of hashing techniques, sir? Whenever I want to find a key, simply I need to apply the mathematical function. Then I go to the table slot and find the address. So in hashing, the search cost equal to order of 1. So, but this is applicable for only equality, sir. Suppose I want to find the address of 22. Apply hashing for 22. Go to table slot, get the address, then get the record. So one mathematical operation and getting the data block where the 22 is present. So the access cost is order of 1. So whenever I have equality, I can apply whenever you have equality, you can apply hashing also. So for this, you can apply hashing also. Of course, hashing performs more better than this one, B plus tree, when it is equality, right? So hashing on what is comedy, sir? Genre name. So I can apply hash index for genre name. For the remaining attributes, I don't have any clue. So since I don't have any clue, compulsorily I don't have any choice. I will go for B plus tree. So this is also gives less cost. Then go to the next one. Hash index or movie.customer rating. Sir, customer rating is a range query. Hash index is not good for range queries, sir. Hash index is not good for range queries. So we don't go for it. And hash index on all attributes. If you apply hash index on all attributes, if all the conditions are equality, then it is fine. It will give less time. But here I have range queries also. So these two cannot be. So the remaining two options are A, B. Hope you understood it. If it is MCQ, then I will choose the second option, sir. Okay. Since it is MSQ, I can apply B plus tree on all indexes, whether it is a range query or anything. Anyway, B plus tree is more suitable for range queries, sir. So the answers are A comma B. Hope you understood this. So B plus tree on all attributes, and this is. Now let's go to the next question. With reference to B plus tree of order 1, sir, I think it's not order 1, sir. I think something I done wrong. Because we have more than 2 keys also, right? I think something I done wrong, sir. Okay, fine. Let me continue. Let us check it. We will see, sir. If the question depends on the order, then we will skip it, sir. If the question not depends on the order, then we continue. The minimum number of nodes, including the root node, that must be fetched in order to satisfy the following query. What is the query, sir? Get all the records with a search key greater than or equal to 7 and less than 15. So I need to get from 7 to 15. I need to get from 7 to 15. Now, if I get a record from 7, then directly I move to siblings because the leaf nodes are connected. So whenever I am able to get a record with 7, I can get the next records from there onwards. So the only thing is, first I need to get the record of 7. From there, I can go to leaf nodes because the leaf nodes are connected. No need to search again. Now the first question is to get the record of 7. That means to get the node in which 7 is present. How many node access? First I compare 7 with 9. So one comparison, sir. Let me write like this. So we compare 7 with 9. It is less than. So I move to here. I compare 7 with 5. So this node I need to bring. Then I move to right side. I come here. I compare 7 with 7. This I need to bring. So by this time I need to bring 3 nodes. So this is the first node, this is the second node, this is the third node. Now this node is having 7th record. 8th and 9th will be in the next siblings. So 8, 9, 10, 11. This also I need to bring. I need to bring up to 15. 13, 14, 15. This also I need to bring. Right? Then it is 17. It is not needed, sir. So this I need, this I need. So totally how many you need, sir? You need to bring 5 records. 3 records to get 7th record. Sir, 7th record in the sense the node which contain the record with 7 value. Then from there I will follow up the leaf nodes. So 2 more leaf nodes I have 5. So totally 3 nodes to get 7. From there 2 siblings, 2 leaf siblings. Totally how many, sir? 5. I think this is what they asked, sir. Minimum number of nodes I need to fetch. So that is, of course, this is not order 1, sir. That may be something else. So anyway, since the order we are not using in this question, we can do it. So how many records you are fetching, sir? You are fetching 5 records. So the answer is 5. Hope you understood it. right? So that is about files and indexing and problems on multi-level indexing. In the next session, we will start AR diagrams. Thank you.